So, good morning students. Let us continue with Pythagoras theorem from where we have left out. This is for 10th class state and Cbse. So Icse they don't have this, so they can ignore it. Let me read out the question for you. The perpendicular AD on the base BC of triangle ABC intersect at D. The perpendicular AD on the base BC AD on the base BC of triangle ABC intersect at D. So that DB is equal to, they have given DB is equal to 3 times CD. Prove that DB is equal to 3. Prove that 2AB square is equal to 2AC square plus BC square. So very important question. Triangle ABC is there in which AD is drawn perpendicular to BC such that DB is equal to 3 times CD. DB is equal to 3 times CD, and we have to prove that 2AB square is equal to 2AC square plus BC square. How to do this one? It's very simple. Here there is no construction, nothing, just go with the diagram. Next, how to do this one means, here BD is equal to what is given 3 times CD, right? So from this calculate the length of BC. BC is equal to, how will get BC? BD plus CD, right? So BD is nothing but 3 times CD, no? 3 times CD plus CD. So 3 plus 1 is 4 CD. So BC is equal to 4 times CD. Therefore CD is equal to, bring this here, 1/4 of BC. That means this is 1/4 of BC. This is BD is nothing but like that. So CD is equal to 1/4 of BC. Right? Next. So this we calculated, CD length we calculated, and that's it. Let's go for Pythagoras theorem statement. Right angle triangle square on the hypotenuse is equal to sum of squares on the other two sides. So AB square is equal to, what can you say? AB square on the hypotenuse is equal to sum of squares on the other two sides. Consider triangle, here we should write, consider triangle ABD. So ABD square is this one, square on the hypotenuse is equal to sum of squares on the other two sides, BD square plus AD square. Right? Next, again consider this triangle. Consider triangle ADC, right? Consider triangle ADC. Now in this is the hypotenuse. AC square is equal to AD square plus CD square, right? Now here AD square both are same, no? So bring this here and here, bring this here. This implies what? AB square minus BD square is equal to AD square. This implies AD square keep as it is. AC square minus CD square is equal to AD square. Right? Both are same, no? RHS, therefore we can equate these two. Are you following what I am saying? So from this AD square is equal to this one. Or else you can write directly AD square is equal to hypotenuse minus this one, and AD square is equal to hypotenuse minus this one. Therefore equate both, because AD square both are same. So therefore AB square so here what you have to write is, this time erasing this one. So AB square minus BD square is equal to AC square minus CD square, right? So AB square write as it is minus BD. BD is given no 3 times CD. 3 times CD whole square, right? This can be written as like this, is equal to AC square, right, as it is. CD square, just now we found no, CD is nothing but 1/4 of DC. Here 1/4 of this, just refer to the diagram, refer to the simplification what I have written just now. Next, AB square minus 3 times CD. CD is here, BD is equal to 3 times CD is equal, no? 3 times CD, just now what we have found, CD length is 1/4 of BC, is equal to AC square minus this one calculation 1 square by 4 the 16 BC square, right? Here understand this statement carefully. BD is nothing but 3 times CD, right? Or you can come back to this. BD is equal to 3 times CD, right? 3 into CD. What is CD? Again 1/4. 1/4 of BC. So 3/4 of BC. You can write here CD. You can write here BD is equal to 3/4 of CD. You can write directly over here. BD is nothing but 3/4 of BC. So expand this one. 3 3s are 9, 4 4s are 16 BC square. Right? Are you following what I am saying? BD again. This can be written 3 into CD given, no? CD. Just now we calculated CD length is 1/4 of BC. So in place of CD, you write down 1/4 BC. So it is nothing but 3/4 BC. Now bring this to that side, right? Because keep in mind what you have to do. 2AB square. AB square is equal to AC square plus this 9 minus 9/16 can be written as plus 9/16 minus 1/16 BC square, right? So AB square is equal to AC square plus 16 and 6. What is the LCM for 16 and 6? I think 16 and 6. What is the LCM for 16 and 6? 48, I think. 48 is the LCM. 16 3s are 3 9s are 27 minus 6 8s are 48, 8 1s are 8. So 9 minus 16 and 6 LCM I took. So 48 I got. 16 3s are 3 9s are 27. 6 8s are 48, 8 1s are 8. 27 minus 8. 27 minus 8 is 19. What is this? 9 by 16. 16 and 6. 27 minus 8. 19 we got. BC square. Just wait a minute, some calculation. 9 by 16, bring here. Oh, I'm sorry. Here both are same, no? Please make a note of. I'm sorry, here I have written 16, here 16. By mistake it is written as 6, it is 16. Please make a note of it. Here I have written 6 instead of 16. 3 square by 4 4 the 16, 1 square 4 4 the 16. Both denominators are same. So you can add the, you can subtract the numerator. So 16 is 9 minus 1 BC square. So AB square is equal to AC square. 9 minus 1 is 8 by 16 BC. 8 1 the 8 2 the 16. Next. So here 2 we got. AB square is equal to AC square plus 1 by 2 BC square. So multiply all the terms with 2. 2AB square is equal to 2AC square plus BC square. So there ends the problem. So once again I will explain this problem. Given that DB is equal to 3 times CD given. So from that CD I calculated, what I got is 1/4 of BC. So 3 into CD. CD is nothing but 1/4 of BC. Write like this. Then apply Pythagoras theorem for this triangle and this triangle. Then you will get like this. So here what is the mistake I have done is instead of 16 I have written 6. That's why it took this. That's why it took this much of time. So 16 LCM both are same, so can subtract. So here we got 2. Multiply each and every term by 2. There ends the problem. Very simple but interesting. Interesting problem this is. Next one. In a triangle ABC, AD is drawn perpendicular to BC. This is objective type question, very simple. In a triangle ABC, AD is drawn perpendicular to BC. AD is drawn perpendicular to BC. Prove that AB square minus BD square. AB square minus BD square is equal to AC square minus CD square. So like I said, this is just nothing but continuation part of the previous problem. So AD triangle ABC in which AD is drawn perpendicular to BC. Prove that AB square minus BD square is equal to, they have given like this. Simply consider simple problem. Consider triangle ABD, right? ABD, right? So AD square, what you will get? AD square is equal to, consider triangle ABD in which angle ADB is equal to 90 degrees. In this angle ADB is 90. So square on the hypotenuse is equal to sum of squares on the other two sides. But I want this length. So AD square is equal to hypotenuse square minus BD square. This one. Hypotenuse square minus BD square will give this one. In the same way, consider triangle. Consider triangle ADC. This triangle. This triangle you have to consider now. Now I want AD square. How will get this length? Hypotenuse square minus this length. This longest square minus this length is equal to AC square minus DC square, right? Now see here AD both are same. So you can equate LHS are same. So RHS. AB square minus BD square is equal to AC square minus DC square. So there ends the problem. Very simple. I don't know, this is nothing but part of the previous problem. So already I have explained previous problem and this once again I have explained this. It's very simple. Next one. Very important question. A point O in the interior of rectangle ABCD is joined to with the vertices ABCD. Prove that a point O in the interior of rectangle ABCD. Somewhere, interior means somewhere like this. I am taking here and join this. A point O in the interior of rectangle ABCD. In the interior of rectangle ABCD means here ABCD is the rectangle, is joined with each other vertices ABCD. Prove that OB square plus OD square is equal to OC square plus OA square. Right? How to do this one? So in order to this one, OB square plus OD square, OB square plus OD square is equal to OC square plus OA square. It's very simple question, but you need to understand only one, that is construction. Draw construction, very important statement. Construction, very important statement. Draw L, draw PQ, draw or something, draw a line L parallel to BC. Draw L parallel to BC, meeting DC at P and, right, meeting DC at P and AB at Q. Right, are you following what I am saying? You have to draw one line parallel to BC such that this line intersect DC at P and AB at Q, right? So therefore, if in a rectangle each angle is 90 now, so that means this angle P and angle Q is also 90. Why? Because this is parallel to, in a rectangle, so this is parallel to this one, right? So each angle is 90. So this angle will be 90. How it is 90? The sum of interior angles of a triangle, the sum of interior angles is always 180. When you measure this and this, the sum should be 180 because these lines are parallel and this is a transversal. The sum of interior angles lying on the same side of transversal is 180. Please remember that one. So here what is important is, once again I will repeat, draw a line L parallel to BC such that DC meets, such that what? Meeting, such I have written, such that this line meets, intersects CD at P and AB at Q. You have to draw a line parallel to BC such that this line meets DC at P and this line meets AB at Q. Now what I am saying is, the sum of interior angle lying on same side of transversal is 180 provided the lines are parallel. So this line is parallel to this line is parallel to this one, no? So sum of interior angles lying on the same side of transversal, sum of interior angles lying on same side of transversal is 180. So therefore angle OPC is equal to angle C. Both are equal to 90. Why? Because sum of interior angles lying on same side of transversal is 180. So you can write here the statement what I said just now. Sum of interior angles lying on same side of transversal is 180. So obviously this is 90. So this is 90. This is 90. Right? So consider BQCP is a, now what kind of quadrilateral it is? BQCP, it is a parallelogram because a quadrilateral in which each angle is 90 is a quadrilateral in which one angle is 90 is a rectangle. Please remember that. So BQPC is a quadrilateral in which each angle is 90, so therefore it is a rectangle, right? So in a rectangle opposite sides are equal. Are you following what I am saying? Therefore you need not write all. If you want, if you have time, you can write all the steps whatever I have just explained just now. Therefore this angle P is equal to angle C and also angle OQB is equal to angle B, both are 90. So why these are 90? You are saying this is 90, this is 90 because sum of interior angles lying on same side of transversal is 180. Sum of interior I don't have term, that's why I am writing in short form. Sum of interior angles lying on same side of transversal is 180. Therefore this statement will come. Now therefore BQPC is a rectangle, right? And again similarly AQPD is a AQPD is a rectangle. So until here any doubts? So I have explained clearly why this becomes a rectangle, why this is a rectangle, and each angle why it is a 90. Now consider Pythagoras theorem. Now come back to this Pythagoras theorem. So consider triangle, this triangle. Consider triangle OPC. Consider triangle OPC. Square on the hypotenuse. OC square is equal to what? OP square plus PC square. Right? Next, again consider triangle. Here OD square is given, no? OD will come where? This one. OC square is there, OA square. I want to consider this one, OA square. Consider triangle OAQ. Next, what can you say? OA square is equal to square on the hypotenuse is equal to sum of the squares on the other two sides. OQ square plus AQ square. Right? Consider this triangle and this triangle. Why we have to consider? Because OC square plus OA square. So I will get the answer OC square plus OA square. So from this OC square plus OA square, adding these two, adding 1 and 2. So adding 1 and 2. So OC square plus OA square is equal to what you will get? OP square plus PC square plus OQ square plus AQ square. Right? Are you following what I am saying? I have added these two. OC square plus OA square is equal to OP square plus OQ square. OP square plus OQ square. This one I added like this. This and this I added. I got the answer like this. Now OC square plus OA square is equal to OP square plus PC. Where is PC? A, B, C, D. PC is nothing but in a rectangle opposite sides are equal, no? So PC is nothing but BQ. In place of PC, very important, in place of PC, BQ square. This step is very important. Plus OQ square, write as it is, plus AQ. What is AQ? In place of AQ, in a rectangle opposite sides are equal, no? AQ you can write as DP square. PD square, right? Now OP square plus PD square. Now club these two and club these two. OP square plus PD square. Club these two means just interchange. Plus BQ square plus OQ square. Now OP square plus PD square. OP square plus PD square. What can you say about this? This is a right angle triangle, right? OP square plus PD square is nothing but OD square plus BQ square plus OQ square. BQ square plus OQ square. Square on the hypotenuse. Square on the hypotenuse is equal to sum of squares on the other two sides. So BQ square plus this square will give this one. OB square. So it is there, no? OB square plus OD square. So hence the theorem. Therefore I started with OC square plus OA square and I ended with OD square plus OB square. So there ends the theorem. Very, very important, and it may come for exam also for 10th and for 10th class state and Cbse. This is Icse students, they don't have this one. They can ignore this. If they want to listen or if they are really interested in doing Pythagoras theorem theoretical problems, they can go through the videos of what I have done so far. Thank you students, have a nice day. Don't forget to subscribe my channel. Please click on the blue color icon button and subscribe my channel. Have a nice weekend. Bye. Thank you.